Today we're going to talk about calculus in the context of the physics of motion. And calculus was actually invented to describe the physics of motion. And so I think it makes a lot of sense, a lot of intuitive sense when you talk about calculus in the context of motion, because motion is something that we experience daily. We understand things like distance and speed and velocity and acceleration because we've experienced it. And so that's what we're going to do today. So the first thing I want to do is just define some terms. In physics, some of these terms have a very precise meaning. For example, the difference between distance and displacement. So the distance you are from something is just a measurement, but it doesn't have any direction involved. So I might be, say, 10 miles to the west of Minneapolis, and you might be 10 miles to the east of Minneapolis. Now, our distance from Minneapolis is the same, but we're obviously not in the same spot. So, distance is just a scalar measurement. It just measures how far you are from something. Now, displacement is a vector quantity, meaning that it has a direction involved. So it has a magnitude and a direction. And the magnitude of displacement is a distance, but displacement also includes a direction. So, I might be 10 miles west and you might be 10 miles east. So that would be a displacement measurement. There's also a similar distinction between speed and velocity. Speed, again, I might be traveling 60 miles an hour down I-35, but I might be going south. Now, you might be also going 60 miles per hour on I-35, but you might be going north, right? Our speeds are the same, but our velocities are very different because we're traveling in different directions. So velocity is a vector quantity, and it has magnitude and direction, whereas speed is just a magnitude but no direction. Acceleration is also a vector quantity, so it has a direction. It has both a magnitude and direction. Okay, acceleration is just the change in velocity over time. So you might notice that speed is how velocity is how displacement is changing over time. Acceleration is how velocity is changing over time, and so the derivative of your displacement is your velocity, and the derivative of velocity is acceleration, which is actually the second derivative of distance, right? Because the derivative of the derivative is the second derivative. Now, you know how to take the derivative of a function, but sometimes we're given information about, say, velocity, and we want to know something about the distance. Or maybe we're given some information about acceleration, and we want to find something out about the velocity. And so it might be nice to be able to go the other direction, not only take a derivative, but also go backwards. And that's what we're going to start to talk about today. That's actually what we're going to be talking about for the rest of this class, is how to go backwards, how to take the antiderivative, going backwards, taking a derivative and getting information about the original function. And but today we're going to talk about linear motion, which is just motion in a line, one dimension. And you might think, well, that's pretty simplistic, but it's actually very useful because, in the real world, we're working in 3 dimensions, but we can break 3-dimensional problems down into 3 one-dimensional problems. And so really, this idea of working in 1 dimension is kind of the critical thing to be able to work in more than 1 dimension. So when we're working in 1 dimension, we can just think of it as working on a number line, okay? And we can use the positive or negative sign as the direction. So the direction is just positive or negative. We don't need any special, it's not like we need another number. We just use the either positive or negative sign to indicate direction. All right, so let's take a look at example 1. We have 2 objects, A and B, and they're moving on a number line at the given speeds and directions indicated by the arrows. So what is the displacement of object A relative to the origin? All right, so object A is right here. So you highlight it. This is object A, and we are at, looks like this little point is at -4. So the, whoops, the negative sign actually indicates the direction, right? So how far are we, which side of the origin are we on? So we're on the negative side of the origin, so we're to the left of the origin, and we're 4 units. So our direction is negative, and the magnitude is 4 units from the origin. So I'm just going to say units. We don't really have there's no like centimeters or meters or or any normal units on this number line. So I'm just going to call it a unit, whatever that is. All right. How about object B? Object B, what is its displacement from the origin? Well, here we're at 6. We're at +6, right? So its displacement is +6 units from the origin. Okay, so we're using the positive sign to indicate that we're to the right of the origin. All right, so so these quantities have both magnitude and direction, and the direction is just indicated by the sign, by the either negative or positive. All right, so what is the velocity? What is the velocity of object A? Well, it tells us. It tells us it's 3 units per second, right? So 3 units per second. All right, that's how fast that object is moving. But it's moving in a direction, right? We need a direction here. And it's moving in the positive direction. If we take moving toward the positive side of this axis, right? We can call this as this positive direction. So it's moving in the positive direction, right? So its distance from the origin is decreasing, but it's becoming less negative. You could kind of think of that. But it's moving in the positive direction. All right. Now, how about object B? Now it's moving in the opposite direction. It's moving toward the negative side of the axis. So so we would say that this object is moving at a -2 units per second because it's moving in the negative direction. We call this the negative direction. You can see though that it's as time goes on, its distance from the origin is decreasing, right? So so it's moving in the negative direction. Now it could be moving in the negative direction over here, but now its distance from the origin is increasing, but it's becoming more negative, so it's decreasing. Okay, the displacement is becoming more negative. All right, well, that's all I have for this example, and I will meet you in the next example.